Hey guys, so today is finding the volume of a region rotated about a horizontal line. So we're still doing everything in terms of x for this problem. Tomorrow we'll be doing in terms of y, but today is in terms of x, but we're not rotating around the x-axis a horizontal line. So this one's going to be a little different. It's the same process though. We're just moving our axis of rotation. All right, so pause the video and try the problem. Remember, limit yourself to 2 minutes. It says a tank contains 50 liters of oil at time t equals 4. So notice that's your initial amount. Oil is being pumped into the tank at a rate R of t, where R of t is measured in liters per hour, and t is measured in hours. Select values of R are given in the table above. Use a right Riemann sum. Okay, so I always like to just draw my rectangles. It just makes more sense logically for me. So I have 3 subintervals, it says. So those are my 3 rectangles, and I'm using a right Riemann sum. So this distance is 3, this distance is 5, and this distance is 3. All right, so the initial 50 plus the integral from 4 to 15 of this pen R of t dt. So we get 50 plus. So I have my distance is 3. The right side has a y value of 6.2 plus my width of 5 with a right Riemann, the right side is 5.9, and then 3, 5.6. So we're going to add all that together, and I got 114.9. I did this without a calculator. My guess is this is calculator, based on the numbers, but you can do this without a calculator. I was able to. All right. So we've done this problem before, but I'm changing it up because now we are rotating about the line y equals 4. Find the volume of the solid generated by revolving the region bounded by the square root of x. So we have the square root of x, the x-axis, and the lines x equals 4 and x equals 9. And we're rotating about the line y equals 4. Now, one important point here is we're not cutting between the region. That would make life more difficult. So our horizontal line is above because this point is 3. So that does make a difference. Okay. So this is my region. So imagine it's going to flip up here. And it's kind of like this. And like that is your weird shape. So this is the shape that we're making. Oops. So remember, the key here is little r and big R, okay? So big R is the distance from, that's ugly, from the axis of rotation to the farthest function. I'm struggling, guys. Struggling. Come on, erase. Fine, don't erase. R equals. So my axis of rotation this time is at 4, right there, and to the farthest part of the graph. So now here's the question. What is that distance? Think about it. What is that distance? That distance is just 4. So big R is 4. Little r, I'll do this yellow, I'll try yellow, see if that comes out, is from my axis of rotation to the closer piece. So what is that distance? Well, that distance is, I'm going to try highlighting, this whole thing, the red, minus this green. So it's going to be 4 minus the function. 4 put it in terms of the pen would be helpful. 4 minus the square root of x. Okay. So big R, the distance to the farthest spot, that's a distance of 4. The little one, right, this piece, let me get to this. So big R is this distance, and it's always 4 no matter where we draw our line. And then this little piece is the whole thing minus the function. So that is the setup. And once you have this setup, it's really not a hard problem. Everything else is exactly what we've been doing in the past. So we've got pi from 4 to 9. Big R squared minus little r squared. So 16 minus 4 minus the square root of x squared dx. I actually did do this problem out because I was like, oh, I can do this problem. So I got, I multiplied the inside out. I got 16 minus 16 plus 8 root x minus x. So I ended up getting 9. So 8 root x minus x dx. I did the antiderivative and I got pi times 16 thirds x to the 3 over 2 minus x squared over 2. And then from 4 to 9. I plugged in and I ended up using a calculator because the numbers were gross. And I got 214 plus 675. Alright, so check that you get that as your answer. Alright, 2002 exam. Let f and g be the functions e to the x and ln of x. So let's draw a quick picture of that. E to the x looks like that. Ln of x looks like that. Find the area of the region enclosed by 1/2 and 1. Alright, so 1 is right here. We have that region and 1/2. So this is the region, that's the area we're finding. So this is pretty basic. It's just top minus bottom for area. E to the x minus ln of x dx. Now, we have to use a calculator. We actually don't know how to find the antiderivative of ln of x. To tell you the truth, I don't even remember the answer off the top of my head. I'm pretty sure it's a weird answer. I can't remember, so you have to use we don't have a method right now. After the AP test, I might teach it to you, but we don't have a method for doing the antiderivative of ln of x. So we get 1.223. Okay. Find the volume of the solid generated when the region is revolved around the line y equals 4. So y equals 4 again is up here. There's my line, y equals 4. And the key here, oh no, is finding big R and little r. So big R is the distance from my axis to the farthest thing on the graph, to the farthest region. So that, what is that distance? So think about it. Come up with an idea. It's going to be 4 and then plus that distance minus ln of x. What's that? 4 minus ln of x. Because if you think about it, if we did like over here, this distance, why aren't you working? There it goes. Like this distance is also, it would be the whole thing all the way to here. Oh my god, I'm struggling with this pen today, guys. So this whole thing is 4 minus the function equals this piece. So it's just 4 minus ln of x, because the ln of x is below, so we have to switch the sign of it. Alright, so then what would little r be? Little r, I'll do that one in blue, I guess. I'll do yellow. Is from here to there. What is that distance? It's the same thing. So you should notice a pattern. It's the axis minus the function, right? The y value that we are rotating around minus the function. So we're going to integrate pi r squared. Don't forget your pi, that's a big mistake. Big R squared, 4 minus ln of x squared minus little r squared. And I would never in a million years want to do this problem by hand. What is the answer? The answer is 7.515 pi. And that is your answer. You could also multiply it out by pi, but plug in your calculator, what do you get? Right? We're not doing this by hand. All right, so here is the answer. So no, I had that as my answer. You can also multiply out by pi. Notice the way that this is graded. We have our integral, just putting in the integral, knowing e to the x minus l and the x gets you 1 point. The answer, just plugging in your calculator gets you a point. The limits and the constant. So you need both the 1/2 the 1 and the pi to get that point. The integrand, so you have to have this quantity squared minus 4 minus e to the x quantity squared. So those are the 2 points that you get. You won't get any points if it's not in this form. And then finally 1 point for the answer. All right, pause the video. I want you to try this one on your own. So number 1 is from this is from 2002B. So there used to be 2 forms every year, a regular form and then form B. So this is from 2002 form B. So use your calculator. I wanted you to practice rotating about a y value. So this is the part B was not actually on the AP test. They asked it a little differently. But try it. All right, so the first thing we need to do is find this point. Point of intersection is 1.48766, comma 1.02467. And then I always save that in my A and my B. If you need help with the calculator work, let me know and I can make a video. So for the area, it's just 0 to A, top minus bottom, and be really careful plugging that into the bottom. Oops, that's a squared. Make sure you put parentheses around the bottom. And I plugged that in my calculator, and I got 3.215. All right, rotating about the line, y equals 4. Well, 4 is the y-intercept. All right, so we need this to the farthest point, right? So that is big R. I know it's region R, but I like using big R, little r for radius. Sorry if that's confusing. All right, so that distance is this whole thing, 4 minus green. Blue minus green equals red. So blue is just 4 minus the green, that's your x cubed over 1 plus x squared. So that's your big R. Little r is from the R to the closer part of the region, so that distance. So little r is that, again, that whole thing, that the line we're rotating around minus the function, and be really careful with parentheses for this one. You need 4 minus 2x. So to write the integral, pi from 0 to a, big R squared minus little r squared. Big R was 4 minus x cubed over 1 plus x squared. 4 minus 4 minus 2x squared. Now remember I told you this is why I use y1, y2 because it's really easy to mess up typing these. typing in your calculator 4 minus y1 squared minus 4 minus y2 squared will make far less errors in typing than typing out the whole function. So this is really the reason I wanted to get you into the practice of that. It's so easy to type, like you mess one tiny thing up and you're missing, you got the wrong answer, which is really frustrating. So I got 15.567 pi, which is 48.906. And that's it. So let me know if you have questions. We will talk about this tomorrow. Again, the most important part of this lesson is identifying what's your big radius, your little radius. Only 3 problems for homework. I will see you guys tomorrow. Let's make it Hannah today. Hannah, you dyed your hair blue. Oh no. And there's her 5. All right. Bye, guys.